Now here we have a bit more sophisticated polynomial expression, which is we're asking to determine when is it greater than 0. So, and it's not so bad because it looks like we can factor this fairly easily. Let's see what happens, okay? So in the numerator, of course, we're going to factor this x plus 3 and x minus 3. And in the denominator, it looks like we can pull out a 6x squared as a common factor, and then be left with x squared minus 3x minus 4. So we want to factor that again. X plus 3, x minus 3 over 6x squared. And what are we going to factor this as? Let's see, just x minus 4 and x plus 3. Okay. Now, so a couple things to make note of. Let's just double check this factoring. That's negative 4x, and that is positive 3x, which gives us which is not the factors we want. That's supposed to be 1 there, obviously. Okay, good thing we just we checked. Okay, so I guess it's minus 4 and plus 1. Right, that's negative 4x, and then that's positive 1x. So now we are fully factored. Okay, so and of course, since this is a fractional expression, and we are effectively first solving this for 0, we want to make note that x cannot equal 0, 4, or negative 1 for reasons that would define, would be leaving the denominator with 0 and therefore an undefined expression. So let's look at what we have. We have 1, 2, 3, 4, 5 factors. So those 5 factors want to be represented in my sign table, and we'll build the sign table down here, mind you, with those factors as intercepts on effectively the x-axis. So what do we have to be concerned about? We've got in terms of when is this equal to 0, okay, we have x can equal 3 or negative 3. Now these values, even though they're not values that can be equal, they are values that we're going to be concerned with and putting in our sign table. So let's get them in there. Okay, they're not equal to 0. I mean, they set the denominator equal to 0, but they still give rise to interest because we want to know what happens left and right of those values, okay, when the graph is ultimately plotted. So we're going to represent them in our sign table. Okay, so from left to right, we have negative 3 as the first point of interest. Okay, then we have negative 1. Then it looks like we're going to pick up 0. And then we have, then we're going to pick up 3. And then we're going to pick up 4. Again, these are the values of points of interest on the x-axis for what we will ultimately end up wanting to graph, not this time, but sometime down the line. But when we factor the expression, every factor, okay, contributes a point of interest on the x-axis. So the negative 3 factor comes from the negative 3 as a point of interest comes from the x plus 3 factor. The negative 1 comes from the x plus 1 factor. The 0 comes from the 6x squared factor. The 3 comes from the x minus 3 factor. and the 4 comes from the x minus 4 factor. Now remember, these points are points of interest on the x-axis that we're concerned with because we want to know whether the graph goes above or below those points above or below the x-axis in and around those points. And so in order to determine that, we build a sign table. Now, the order which they appear here, left to right, is the same order that they appear here going downward. Okay, top to bottom. Now, we're going to try to streamline this sign table approach here. Okay. And previously, we represented the a representative number was chosen in each of these intervals, plugged into each of these factors, and determined whether that factor yielded a positive or negative. Okay, we can streamline that somewhat. We know that the factor x plus 3 equals 0 at negative 3. So when you have values less than negative 3, negative 5, mind you, or anything, this region is going to be negative. And it transitions from negative to 0 and will be positive in all other regions. Okay, and you can easily verify that. Just make sure these regions are lined up. Okay, so in other words, x plus 3, okay, transitions from negative to positive, left and right of the negative 3 value. Likewise, x plus 1, which is 0 at x equals negative 1, transitions from negative to positive, left and right of this value of negative 1. Okay. Here's one that you have to be careful about. 6x squared. It is being squared. Any value squared is going to be positive. Multiply it by 6, it remains positive. So this 6x squared will not transition left and right of 0 because it will always remain positive in every region. Now be careful, because if that were negative, you'd have to just the opposite. Okay, now we have x minus 3. X minus 3 becomes 0 at the value of 3. So for all numbers up until that point, it is going to be, okay, negative. Negative there, negative in this region, negative, negative, okay. When it hits 3, what? It goes to 0. For values greater than 3, 5 minus 3, positive, you know, even 3.5, a number in that region. Again, it's going to be positive in all those. We're trying to streamline this sign table progression. Okay, and lastly, x minus 4 will be negative all the way up till it hits negative 4. So it's negative there, positive there, and okay, that's where it transitions. So it's negative in all these regions. Okay, now this is the sign table is generated. Each of these product. Now I know it's both a product and a quotient, but nonetheless, whether you have products or quotients, okay, sign numbers work the same in terms of the answer, whether they're dividing two negatives or multiplying two negatives, the rule remains the same. So keeping that in mind, here we have 1, 2, 3, 4 negatives and 1 positive. So the product and or quotients of 4 negatives is going to be positive, along with the positive. That's going to be a positive region right there. Okay, here is, okay, 2 positives and 3 negatives, which is going to yield us a negative region. Okay, looks like I forgot to put the negative down in there, so account for that. 1, 2 negatives is positive, along with the rest of those. That's going to be positive. Okay, 1, 2 negatives here. All right. 2 negatives is a positive along with the rest of it. That's going to be positive. Okay, 1 negative. That's going to make that region negative. And all positives is positive. Now, what would we ask? We were asked to determine the regions where this expression will be greater than 0. And the sign table helps us with that because it says in this region, which is the region from negative infinity up to negative 3, okay, is a positive region. Now, can we include negative 3? Yes, we can. Okay. Then we pick up this region from negative 1 to 0. Okay. Now, negative 1 to 0. Okay. Neither one of the negative 1 and 0 can be included. Even though this says they want to include it, we said from up here, it cannot be negative 1 or 0. So therefore, we have to put this as the not included region, as the not included endpoints, negative 1 and 0. And then we get 0 to 3. So let me just clean that up a little bit. So we've got this region in union with, okay, negative 1 to 0, not inclusive of those, not in union with 0 to 3, and we can include the 3. And lastly, in union with the 4, we can't include the 4, okay, but we have 4 comma going out to infinity. So there's 1, 2, 3, 4 regions where this expression will be above the x-axis. Okay. Now we completed that, and now we want to take a look at that from the graph. Okay. So I have put this into my graph, as we can see over here in the y6 value. When I graphed it, I redefined my window because it gets a little scrunched up. Okay, so my window is set this way. Okay, here's my window. -8 to +8 on the x-axis, and very narrow band along the y-axis from -1/2 to +1/2. With that in mind, I was able to construct a graph, and here is the graph. Okay, and okay, here's what's happening. Okay, so the vertical lines are exactly the lines where the graph is not allowed to take on those values. That's okay, the value of negative 1, okay, negative 0 and 4. Okay, so within those values, it's not allowed to assume those. Hold